Hey guys, welcome back to another edition of Algebra 2. Mr. Anderson here with you, leading you through another section in Chapter 6. We're in 6-7. Today we're going to talk about solving radical equations and radical inequalities. And I promise you it will not be 35 minutes today. How about that? It'll be shorter. Okay. All right, let's get to it. Objectives. First of all, we want to solve equations containing radicals. Number 2, we want to solve inequalities containing radicals. Okay. All right, so here's kind of the basic premise that we're going to use to solve these equations. Step 1. Whoops. Oh, that's pretty good. Step 1. Let's just underline everything there. Step 1, isolate the radical on one side of the equation. So wherever that radical is in the equation, we want to get it by itself on one side. Then whatever root it is, like if it's a square root, then we will raise it to the second power. Remember, the second power gets rid of the square root, and the third power gets rid of the third root, and so forth. And then we'll solve the rest of it. So let's take a look and see. It makes more sense when you actually see it being solved here. All right, so here's our first one that we're going to do. We have the square root of y minus 2, and then minus 1 equals 5. So the first step was to get the radical by itself. Well, notice we've got the radical here, but we've got, what, minus 1 attached to it. So what we have to do is get rid of this minus 1. Well, how do you think we might want to do that? We'll do it like we've done before. To move it to the other side, if it's minus 1, we do plus 1. So those cancel. So now what we've got is the square root of y minus 2 equals 6. Okay, so the radical's by itself over here. So what undoes square root? Squaring it. So if I want to get rid of that, I square it. So these cancel. All I have left now is y minus 2. Well, what do I have to do? If I square that side, I also have to square this side. So 6 squared is 36. And then the last step, we just finished solving this, plus 2 plus 2. So y equals 38. That's pretty good, right? Now keep in mind, on these equations with radicals, we can possibly get what's called extraneous solutions. And let me see if I can't spell this correctly here. Kind of like extraneous. Extraneous solutions. So basically what that means is sometimes when we solve these equations, we can get an answer and it looks like it's a good answer the way we solved it, but it really doesn't work in the equation. So that might happen sometimes. So with the radical equations, what you need to do is take your answer and plug it back in to make sure that it's really a solution. So you need to check them. So in this case, 38, I'm going to plug this back in here. So here's my check. I've got 38 minus 2, and then of course minus 1 equals 5. What's 38 minus 2? 36. So I have the square root of 36, which is 6. Does 6 minus 1 equal 5? It sure does. And so that is a good answer. Okay, that is a good answer. Okay, so remember on these to check your answers, because sometimes they will not be correct even though you did everything correctly when you solved it. It just doesn't work out. All right, next one. Let's look at another one. Now this one's a little more involved here because we've got 2 square roots. And if this happens, if you've got a couple of square roots, pretty much basically what's going to happen is you're going to have to get rid of one square root, kind of the way we just did, and then there's still going to be a square root left after that, and then we're going to have to like square it again to get rid of the other square root. So it's kind of multiple steps on this one. All right, well, let's start out. Let's start with the big square root here and get rid of that first. So if it's the square root of x minus 12, to undo the square root, I take this and I square it. So what I have left is x minus 12. Now, if I'm going to square that side, I have to square this whole entire side. This is where it's a little bit tricky. And remember what I've been talking about a lot? If you have some sort of a binomial squared, what do you have to do? Write it twice and FOIL it, okay? We're going to have to do the same thing here. So that's why this isn't going to be the greatest, but it's not too bad. So really I've got 2 minus the square root of x times 2 minus the square root of x. I'm going to have to write it twice, and I'm going to FOIL it here. So when I do this, 2 times 2, 4. Outside, that's going to be minus 2 square root of x. Inside, minus 2 square root of x. And then the last, it's a negative times a negative, so it's going to be a positive. And square root of x times square root of x just gives me x. Let's simplify. So I have 4 negative 2. Now remember the rule here about with like radicals. These are both the square root of x, and so they count just like a variable, even though it's a radical. So this is going to be minus 4 square root of x plus x. Okay, so far okay on that? All right, and then we still got this x minus 12 over here. Well, notice we got rid of this one square root, but we still have another little one here left over after we did all that. So basically now what I have to do is kind of do that process again, get everything cleared away from this square root of x, and then I can square it and then finish solving it. So let's do this. I'm going to go, I got a 4 here, so I'm going to go minus 4. And that's going to go with the minus 12 over there. Those will cancel. I'm going to do a couple of steps all in one here just to save some time. So I have a plus x, so I'm going to do minus x. And when I do minus x over here, those cancel, but guess what? These also cancel, don't they? So what do I have left now? I have a negative 16 equals a negative 4 times the square root of x. We're closing in on it. So how do I get this negative 4 away from the square root? It's negative 4 times the square root of x, so I divide by negative 4. So I have the square root of x equals 4. Negative 16 divided by negative 4 is 4. And then to get rid of this square root, now I square that. So it looks like we get x equals 16. Is what it looks like, right? Remember, there could be these extraneous solutions, and so let's double check this to make sure. So we got to plug 16 back in here. So I'm going to plug it in here first of all. Square root of 16 minus 12 equals 2 minus square root of 16. All right, so what's 16 minus 12 is 4. So we have the square root of 4, which is 2. And then here, square root of 16 is 4, so this is 2 minus 4, which is, negative 2. So look at this. 2 does not equal a negative 2, does it? So this, even though we did everything correctly here in solving this, 16 is not an answer. Because when I actually plug it in, it kind of seemed like it should be, but basically it did not work out. And so we have to say there is no solution in this case. So no solution. Okay? So unfortunately, sometimes that's going to happen. Don't feel like you've wasted your time. You have successfully found that there is no solution. But keep that in mind, though. If you have a couple of square roots in there, you might have to square that a couple of different times to get rid of those totally, and that's okay. All right, next. A cube root. Okay, so in this case, A cubed root, or remember what we've been talking about, is if it's raised to the 1/3 power, that's the same as the cubed root, okay? So this could apply to something like this where there's an exponent that's a fraction, or whether it's written out as a radical. It can work the same way. So we follow the same pattern. Get the cubed root, or the part that's raised to the 1/3 power, by itself. So I have to minus 5. So now, and again, depending on how you want to do this, you might be more comfortable rewriting this, perhaps, as the cubed root of 3y plus 1. You could totally do that. If you wanted to leave it in this form, you also could. Either way, the next step is the same. What undoes the cubed root? Raising it to the 3rd power. The 3rd root cancels the 3rd power. So I'm left with 3y plus 1. I have to do the same thing on the other side. And so negative 5 to the 3rd power is going to be a negative 125. If you don't believe me. And remember, you know, negative, to pay attention to the negatives there. So I have a negative 5 raised to the 3rd power, negative 125. Oops. So now we just solve for y. Minus 1. 3y equals a negative 126. Divide by 3. And I'm going to need this back over here again. So now we have a negative 126. Negative 126. Okay, why is that doing that? Negative 126 divided by 3. And that's a negative 42. So it looks like we've got an answer of negative 42. But it is a radical, and so we might want to check this answer just to make sure that we've got the right thing here. And so let's plug in negative 42. And I don't know if it matters which way you do this here. I'm going to just use it in the form where it's the cubed root, I guess. So we're going to have 3 times negative 42 plus 1. And since this part here at this step it equaled to negative 5, I'm going to work this out and see if this all gives me a negative 5. If it does, I'm good. So let's see. We've got the cubed root. Go to math. Number 4. Cubed root 3 times, let me move over here, negative 42 plus 1. I think that will be okay without extra parentheses there. And negative 5. That's it. So we're good. We checked this one, and this one checked out. So ding, that's a good one. So y equals a negative 42. That's a good answer. Okay, so doesn't really matter what the exponent, or if it's a fractional exponent or what the root is here. It works the same way. You get the root part by itself, and if this were the 6th root, then you would just raise both sides to the 6th power. So no matter how complicated that gets with bigger numbers, you just follow the same pattern. All right, last thing that we've got to talk about are inequalities now. All right, so radical inequalities, and pretty much with what we're going to deal with here, it's the first thing it says, if the index of the root is even, pretty much everything that we're going to deal with here will be square roots, so they will be even. So here's what we have to do. It says identify the values of the variable where the radicand is non-negative. So basically that means, remember, we cannot have, since it's an even root, like a square root, we cannot have a negative underneath the radical sign, because that would make an imaginary number. That's why this has to be even, because you know we've talked about this, that if it's a cubed root, you could have a negative number under there. So that's why it's only when it's even. So you find out what that value is, then you just solve the entire thing, and then again you test some values. Okay, so let's take a look at a few examples here and see how that works. All right, so step one is we want to see what makes this under the radical sign here. We want it to be greater than or equal to 0. Okay, we don't want it to be negative. So I'm going to first of all solve this little equation here that says what would make 3x minus 6, the stuff under the radical, greater than or equal to 0, or positive. Okay, so this is the first thing I have to do. Just solve this. Plus 6. 3x is greater than or equal to 6. Divide by 3. So it looks like, according to this, x would have to be greater than or equal to 2. Because if it gets less than 2, you're going to have a negative under there and it will turn imaginary, and we can't have that. Okay, now let's solve the whole thing as an entirety, just like we did with an equation, okay? So let's do the whole thing here. So I've got the square root of 3x minus 6 plus 4 less than or equal to 7. First step is get the radical by itself. So to do that, I do minus 4. Square root of 3x minus 6 is less than or equal to 3. 7 minus 4 is 3. Square this whole side and that side. So what I have left now is 3x minus 6 less than or equal to 9 plus 6. 3x is less than or equal to 15. Divide by 3. So it looks like we've got that x should be less than or equal to 5. So here are our two parts. And generally, what you need to know is that both of these things should be true. And we'll check it here to kind of show you how that works. But this looks like what should happen here is that you'd be able to write this. Remember how we wrote our compound inequalities where we kind of smushed them together? It looks like you should be able to write this that x is less than or equal to 5 and greater than or equal to 2. But we kind of mushed it together and put it in the middle. So what this means is x should be in between 5 and 2. Less than 5, greater than 2. So in between 5 and 2. So what you want to do, think of this as being on a number line here. Here's 2, here's 5. We're just going to check it to make sure that this is really okay. We're just going to pick a point kind of in these several different places here just to make sure. Let's start out. We think it's going to be, answers are going to be in here. Let's make sure. What if we pick 0, which is out here? Let's plug it in. If I plug in 0 here, 0 times 3, 0. What do I have left? I have a square root of negative 6. What's the square root of a negative 6? It's imaginary. So guess what? We got an imaginary number when we plug this in out here, so that is no good. We don't like that out there, which is what we expected. Let's try something out here. Let's try 6. We also expect that this is not going to work because we think it's going to be in the middle. So let's look at 6. What if I plug 6 in here? 6 times 3 is 18. Yeah, let's see. Maybe I should write this part down here. So we've got 3 times 6 minus 6. So this is going to be 18 minus 6 is what? Square root of 12 plus 4 less than or equal to 7. Let's bring this over here. So let's just check it out. Second function, square root of 12. Boy, that 2 button is really sticky there, isn't it? I keep getting 1s. 12. So that's approximately 3.46 plus 4. Is that less than 7? No, it's greater than 7. That's 7.46. It's bigger than 7. It's not less than. So that also is not good. And then the last thing, let's try something in the middle. How about 3? Let's try 3. So then I've got the square root of 3 times 3 minus 6 plus 4 is less than or equal to 7. So let's see, this is going to be 9 minus 6. What's 9 minus 6? 3. So let's try that one. Square root of 3 is that 1.73 approximately plus 4. 5.73. Is that less than 7? Yes. And so this is where everything works here in the middle, in between 2 and 5. And so this is the correct answer here. X is less than 5 and also greater than 2. All right, let's just do one more of those, and then that will be it. All right, last one here. Remember, our first step is find out, first of all, what would have to be greater than 0 here. So we do 2x plus 2 is greater than or equal to 0, minus 2. 2x is greater than or equal to negative 2, divide by 2. So the first part is that we have x is greater than or equal to a negative 1. Okay, that's our first part. Now, let's solve the whole thing in its entirety. So I'll do a squiggly line here. So we're going to do minus 1. Whoops, minus 1. So I've got the square root of 2x plus 2 greater than or equal to 4. Well, I was really sloppy on that one, wasn't I? And then take the square root. So you have 2x plus 2 is greater than or equal to 16 minus 2. So 2x is greater than or equal to 14, divide by 2. So x is greater than or equal to 7 is the other part. So there's our two parts. X is greater than or equal to negative 1, and x is greater than 7. Now, this one's slightly different because before it was kind of in between. Well, this is greater than 7, but also greater than 1. Thing to kind of, again, remember is you're looking for your answer where both of these are going to be true. So it looks like, to me, and we're going to test it in a second here on our number line, but here's negative 1 down here, 0, 1, 2, 3, 4, 5, 6, 7 up here somewhere. So it has to be greater than negative 1, so it has to be somewhere in all these numbers up here, but it also has to be greater than 7, so it has to be greater than these numbers up here. So chances are that these numbers in the middle are not going to work either because they're only true for this part, and it has to be true for both of them. So probably our answers are only going to be true out here to the right of 7. So let's just double check and make sure. So first of all, let's try negative 2. That's going to be out here somewhere, negative 2. So if I put negative 2 in here, negative 2 times 2 is negative 4. Negative 4 plus 2 is a negative 2. We've got a square root of negative 2. Guess what? Imaginary numbers. No good. Okay, so that doesn't work out here. We didn't think it would. 0. Let's try 0. We also don't think 0 is going to actually work here either. Again, it'll make this part true, but it should not make the whole thing true. So let's plug in 0 here. It's going to be 2 times 0 plus 2, and then plus 1 greater than or equal to 5. Well, let's see. What's 0 times 2? 0. And so all we have left is just the square root of 2 plus 1 is greater than or equal to 5. Let's see if that's true. Oh, calculator. And so we've got second function, square root of 2 is something went wrong. Let's try it again. Second function, square root of 2. 1.41 approximately plus 1 gives me 2.4. Is that greater than 5? No, it is not. So therefore, the stuff in the middle does not work either. And so as I thought, it's going to probably be the stuff out here, but let's just plug in one more point to make sure. Let's plug in 8. So here's 8 out here. So we're going to take the square root of 2 times 8 plus 2 plus 1 is greater than or equal to 5. Let's see. 2 times 8 is 16. 16 plus 2 is 18. So we have the square root of 18 is what we're checking here. Second function, square root 18 equals 4.24 plus 1 equals 5.24. Is that greater than 5? It sure is. That works. That one works. So what we have to say here in the very end of this is this stuff out here is what worked. These two did not. So our final answer is only going to be given as this right here. X is greater than or equal to 7. That's our only answer, because that's the only place where it actually works. Even though we had this x is greater than or equal to -1, it has to be true not only for that, but also for this one. And this is the only place to the right of 7 where both of those are true. So x is greater than or equal to 7. That's it. All right. Well, that's all for this section, solving radical inequalities and radical equations. Thanks for joining me. We'll see you again next time, and have a good day or evening or afternoon. Bye.